we now move on to interpreting solutions of equations graphically. So this now goes, if you remember what we were working on when we did simultaneous equations, as let's say you had a quadratic as a linear equation, and you wanted to try to find the two solutions to that. That would, and the way you could graph that is, so let's say you had a quadratic equation that looked something like this, and then you'd have a linear equation, and let's say you had two solutions, then the linear equation would go through like that, which the fact that there's two intersections between a quadratic and a linear shows that there's two solutions. Similarly, if you had a quadratic equation like this, but then the line only touches the graph once, then that means that there will be only one solution to the equation. And then similarly, if there's a quadratic graph like this and the line goes like this, then that means there are no solutions to the equation because the lines don't intersect in any way. So yeah, so if you ever have like a question that's asking you to interpret the solutions of your simultaneous equations graphically, that's all you have to do. So yeah, the number of solutions indicates the number of times that the linear equation crosses and the quadratic equation crosses, and how many points that they intersect at. So for example, let's say you have these two equations, y equals x squared minus 4x plus 5 and y equals 2x minus 4, and you want to try and interpret these solutions graphically. What you do is you just equate the two together as they're both equal to y. Then you'll get 2x minus 4 equal to x squared minus 4x plus 5. And then you would just rearrange this to get it equal to 0. So you would get 0 equals x squared, and then if you subtract 2x from both sides, you'd get minus 6x. And if you add 4 to both sides, you get plus 1. Then if you factorize this, and then you can see if you can factorize it, and you would get x minus 3 and x minus 3. So then the only solution is x equals 3. And the next thing you want to do is you want to try and draw the two graphs. So for the first one, you know it will cross at 5, and then you can either complete the square to see where the minimum point is, and if you can try factorize it, but if you try that, you can try this yourself, but you would find that there are no factors. So one way to see whether it crosses the x-axis, you could either complete the square, or you could either use the discriminant. So go back to the videos, and if you don't remember how to do that, try it out. But what you should get is, if you try the discriminant, then you should find out that there are no real solutions. Discriminant would be less than 0. And if you do complete the square, then you would find a minimum value that has a positive y value. So that means it also lies above. So then the graph would look something like this. And then you have y equals 2x minus 4. So you know that will cross at minus 4. And you can figure out where it crosses the x-axis. If you do 0 equals 2x minus 4, 4 equals 2x, so x equals 2. Have x equals like 2 here. Then you know it'll only cross once out when x equals 3. So the graph would look something like this, but more straight. But yeah, remember to use a ruler. And then you can figure out the full intersection of what the y value is by plugging x equals 3 back to the equation. So you would get y equals 2 and then 3 minus 4, which is just 2. So then the solution to this equation is just this here, which is 0.32. So yeah, if it asks you to interpret a solution of, so they give you two equations, like simultaneous equations like this, where it's both y equals something and y equals something, then whatever solution you get, how many solutions you get indicates how many times your linear graph should cross the quadratic graph, and then you can just draw the two and show it using that. So the last bit you need to know is you need to be able to use proportional relationships and their graphs. So so there's two types of proportion. There's direct proportion and there's indirect proportion. So to write out direct proportion, so if you have two statements like saying y is directly proportional to y, you just write y is directly proportional to x. And this is equivalent to saying that y is equal to kx, with k being the constant of proportionality. And so if you were to draw the graph, proportionality. So if you were to draw the graph against, so x is here and y is there, as you know, it's just y equals kx, with k being the gradient of the graph. The graph would just look like something like this. It would just be a straight line going through 0, and the gradient will be depending on what k is. So that's just an overview of direct proportionality. So it could be like y could be the circumference of a circle, and x could be the area, so be the circumference of circles directly proportional to the area of the circle, for example. And another, so then you can also have inverse proportion. Okay, so this is, you could say y is indirectly proportional. If y is indirectly proportional to x, then that would mean y is proportional to 1 over x. And that's equivalent to saying y is equal to k over x. So therefore the graph of an inverse proportion would be, if x is on this side and y would be on this side, it would just be, the graph would just look something like this. Yeah, so if you remember the graph of, so we're just doing it for the positive values of x. So if you remember the graph which was like odd and positive, like something like y equals ax to the power of 1, so let's say it's kx to the power of 1. So that would just, you would just have it on, you would just have it in the top right quadrant and in the bottom left quadrant. So we're just doing for positive values, so it would be in this quadrant. So that is just in a nutshell what proportionality is and what their graphs are. So if we do some example questions, this would make it more clearer. So we have an example here. Y is directly proportional to x when y is 24, x equals 8. So we have to work out the value of y when x is equal to 2. So if y is directly proportional to x, that means y is directly proportional to x, and that means that y is equal to kx. So what we need to do is we need to find out what the value of k is. So we can do that by subbing into the numbers that they've given us. So it'll be 24 is equal to k times 8. So if you do 24 divided by 8, that just means 3 is equal to k. So then the graph would look like, if you have y on this, sorry, if you have x on this and y here, it will just be something like this, which y is equal to 3x. And then we want to work out the value of y when x is 2. We just say that y is equal to 3 times x. We just sub in k is 3, and that's just equal to 6. Now if we do an exam question based on direct proportionality, so pause the video and try the questions for yourself and then come back to the solution. So the question is, the amount of money earned by Sasha is directly proportional to the number of hours she works, 8. If she works for 9.5 hours, she earns £155.80. Express m in terms of h. So we just say, as m is directly proportional to h, we say m is equal to kh. and then she works for 9.5 hours, so we can say H is 9.5, and then she earns £150.80, the M is 155.8 equals to K. H, so then you just do 150.8 divided by 9.5, so then you should get K is equal to 16.4. So then M is just equal to 16.4 H. So then we want to use the equation or otherwise to find out how many hours it would take her to earn £680.80. So you just plug in M as 680.8 equals to 16.4 H, and then we just do 688.8 divided by 16.4, and that should give H is equal to 42. And then if we were to draw the graph of M against H, should get H here, M here, be another straight line with M is equal to 16.4 H. So now moving on to an example of inverse proportionality. So it's saying that y is inversely proportional to x. So that means y is equal to k over x using the definitions we learnt previously. So now it's saying when y is equal to 2, x is equal to 3. Then we want to find out what k is. So we just sub in y is 2. That's equal to k over 3. That means k is just equal to 6. Then we want to work out the value of y when x is 18. Then y is just equal to 6 over 3, which is just 2. So then if you were to draw the graph of x against y, it would just be something like this, with y being 6 over x. Okay, so now we have an inverse proportion exam style question. So you can pause the video here and try it for yourself, and then we can go through it together. So it's saying the time taken, T, for customers to receive their orders at a fast food restaurant is inversely proportional to the square of the number of staff S on duty. So we first want to write that out. So saying T is inversely proportional to S squared. So it's equal to K over S squared. And it takes 20 minutes for customer orders to be taken when there are 4 staff members on duty. So we want to write an equation for T in terms of S. So we can just plug these numbers in. So T is equal to 20, and then that's equal to K over S is equal to 4, so 4 squared. Then if we do 20 times 16, we would get 322 is equal to K. So then it's saying if the number of staff is doubled, how many times quicker will the customers receive their orders? So we want to find out the time when S is double, so when S is equal to 8. So we can plug the values in. So we get T equals 322 over 8. So that's just equal to time is equal to 40. Sorry, not 8. It's 8 squared. Then you'd do 320 divided by 64. So that's just equal to 5. So the time would be 5. So yeah, what I just did there it would be quite a common mistake for loads of students. They would just forget that you want to square it. So just remember what the equation looks like, and just remember to read the question properly. But yeah, that's the answer. So the key to answering inverse and direct proportionality questions is just to make sure you read the information clearly and just write down everything as you go along, and just fill in the numbers and just remember the formulas. The direct proportionality is y equals kx. For inverse is y equals k over x. So just remember that. Yeah, that's everything. So thank you so much for listening to this lesson. I really hope it was useful. So just to sum up what we did, we learned how to sketch graphs of functions up to the power of 4, and we learned how to interpret solution of the equations graphically. So go back to what we were learning about simultaneous equations and try if you can plot those equations using a graph of using what we just learned. And also we learned how to use proportional relationships and their graphs. Thank you.